Q&A for the second day of architecture. So what do we got going on? What are some of the questions people are having? If you have questions about the stuff we've covered so far, I'd like to answer those questions first, as opposed to questions about the stack and calls that are going to happen with the lecture over the next couple days. But that said, I guess just throw them out there and we can start having a look. What do we got? How are things going? Questions that I can answer, or things that you guys are stuck on. Several people. There it goes. I see like two people talking, then it switches to several. And I imagine like 30 people typing at once. All right, let's do the easy one first. 0B before the add, like 0B before the number itself, like when we're doing the const declaration, you mean? This kind of thing. Yeah, so that's so that we can tell, that's how that JavaScript knows that we're talking about a binary number in particular. Because if we didn't put the 0B there, then it would think we were talking about the decimal number 10,101,000. Oops. But by putting the 0B in front, it knows we're talking about a binary number, not the decimal number 10 million. Or put more simply, these are two very different things. Even though the number 10 is there in both cases, this represents the value of decimal 10, and this one represents the value of binary 2. Cool. Yep, it's just one of those cases where because we're writing the number down, it suddenly matters. And we have to be explicit about, oh, hey, this is the base of this number. All right. Stuck on getting files to load. All right, what have we tried so far? There are a couple different ways I know of off the top of my head to do this. The general approaches are either do it a line at a time, read a line at a time out of the file, or read the whole file in at once, and then split up the whole file into individual lines and process those a line at a time. But should I look at the thread? No, okay. But Jeremy, what is up? Feel free to post code snippets, or you can even share a screen if you wanted. Just let me know what you want to do.
Yeah, I can share my screen.
Okay, cool. I'll stop this. Go for it.
Yeah, sorry, let me just get set up here. All right, let me just, you guys see that okay?
Yep.
Okay, so yeah, the approach, I was working with Jeremy Keth today, and we stuck for at least a good hour or more on just trying to get the LS8 files to load. I think it was step 7, if I recall.
Sounds great.
And tried a bunch of things, and kind of where we left off, I just thought of like making a new function here and just trying to bring in like the file name and then load it. But I know there's a bunch of stuff that's missing, and it's just hard to reference things and like know what to look for. Like when we Google it, you know?
Yeah, for sure, for sure. I think in the doc there were a couple hints in there about maybe things to look for. Let me see. What do we have in there? Um, I can't believe I closed that window. Oh no. Why did I close that browser window with all those tabs open in it? I hate it when I do that. Let's see here. I'm just bringing the assignment back up on my screen. Bear with me a second,
Do
everybody.
you want me to stop sharing?
No, it's okay. Uh, we'll stay on your screen. I'm just having to look at the README. Okay. Step 7, unhard code the machine code. Okay, so we talk about process argv0 and argv1 and all that stuff, but I like what you've done there where you've just hard-coded molt.ls8
Yeah.
uh, as a string. Like, you might as well worry about one thing at a time, right?
Mm-hmm.
Like, we got two things we kind of got to do here. We got to process the command line to see what the user typed in, and we also have to read the file in. But by hard coding the name of the file to read in, you're kind of skipping over that first part for now, which is totally good. Like, do one thing at a time. So then let's see. Yeah, there's a hint here that says look at node's read file sync. Did you guys give that a try?
I don't know if Jeremy K wants to chime in here. I'm trying to remember the process we took.
Yeah, I don't remember that part. Where is that in the hints? Not in the hints, but the documentation, I mean.
It's under step 7. It's third from the last paragraph of step 7. This might be a kind of a tricky one to Google for. A lot of them actually are.
Yeah, we were Googling like this read file sync, like this node command here, and
Right.
it just wasn't too helpful, actually.
Let's see. So let me see if I can come up with a good Google thing to use for that. Usually my main search for that is something like node read file sync example.
Oh, yeah, we looked at read file sync. That's right. It had the one little paragraph, but it seemed to be referencing an error. Like it has... yeah, so fs.realpath sync, and then you put in the path, and it gives an example.
Right.
Yeah, okay.
So this is one of those times where Googling is hard, and there are a lot of examples that I see out here that aren't exactly what we want. And I only know this because I know exactly what I'm looking for. But here, stop sharing your screen for a minute, and we'll pop back to mine. And I'll turn it back over. Actually, before I share my screen. Whoa, I'm full screen. I'm looking at myself full screen. It's really huge. Bring this over to the, come on you. Macs are so weird. I'm a top-notch computer user. Okay. So I was looking through examples, trying to find stuff, but I also had here are my examples. Oh, and this is me. Oh, wrong. Got my wrong user here even. All right, this window can come over. Really not on my game right now. I apologize. Okay, so step 7. This was a link straight to the documentation for it, which is a tough read, but we can have a look at it and see what's going on. So read file sync takes a path and it takes some options. So when we read this thing, documentation can be tricky to read, but let's take a look at this and see if we can parse it down. Okay, so the path can be any of these types, it says. It can be a string or a buffer, whatever that is, or a URL or an integer, file name or file descriptor. Well, string is good. I like a string for a file path because we tend to think of them as sequences of letters. And what can options be? Options can be an object or a string, and then options, let's see, options encoding. What does this actually mean? So it's got options and then it has this nested encoding and flag. I don't know. It's confusing, right? Or like, how do I actually read these docs? But it looks like options is optional. Options usually are because it's in square brackets in here. So these square brackets tend to mean, hey, we don't actually have to include that. But does it work if we don't include it? So what do we get back out of that thing? So here's where I'd start experimenting. I'm like, what do I need to know how this works? Let's go ahead and bring up Node, and then I'll. Wait, is it require import? Shoot, totally forgotten. This is what happens when you know too many things. Should I do require or import? Require. Yes. All right, so now I've got fs, which is all that stuff. That's fine. Read file sync should be a function. Great. So let's read a file such as readme.md, which I know I have in this directory, and it returns a buffer. I don't know what a buffer is. That's kind of irksome. But there is this other thing in here that I noticed. It said you can specify an encoding. It says it returns a string or a buffer. I'd rather have it return a string somehow. So how do I get it to return a string? Let's have a look farther on down. If the encoding option is specified, the function returns a string. Otherwise, it returns a buffer. If the encoding option is specified, all right. It says options is an object or a string, which is a little bit weird. So this is where I'm like, what do I have to put here? Do I have to put, how do I tell it what encoding is, and what is encoding anyway? So see if somebody can give me a hint. Oh, hey. I know that UTF-8 is a particular type of character encoding. If I read a file using read file sync file name UTF-8, I have no idea what those other stuff means, but I like this as an example. So I'm going to put that in. UTF-8 encoding. Whoops, I accidentally dropped my command there. Yeah. Now I like it more. I've got a string back. So this is where I would start. Let's try something like that in your code. So read file sync with your file name, and then this UTF-8 out here at the end as an encoding. And then that should return a string that has the whole file in it. So here, I'll stop sharing my screen, and you can go ahead and share your screen again.
Sure.
So that was on line 12.
Yeah.
Comma UTF-8 as in quotes.
In quotes, yeah. Is it -8? Yeah.
I just used 8 without a dash.
Oh, okay.
I wonder if it takes them both. That'd be a good question. All right, so doing that should read the file, and you should save the results in some variable. It's going to return a string. that has the entire file name in it.
Okay, so I would just do it within this load file function.
Yeah,
Like
yeah, totally.
like I could just call it a
Yep.
variable.
Yeah.
File. I don't know. File.
And then this is the point where I'm like, if I were coding this, I'd be like, is this going to do what I think it's going to do? So I do like a console.log or something to
Mm-hmm.
print out the file just to make sure it actually read it in. Although I am confident that this will have read it in because we just tried it on mine.
Yeah. Does this look okay?
Yeah. So read in the file and returns it.
And then down here, I'm just calling the file that I want. And I actually I know I have to do some stuff with this, so it doesn't.
Yeah.
It's going to read all this, but I just wanted to see if it works.
Sure.
I can't remember what the. Sorry, I'm kind of being put on the spot here. I can't remember
That's
what.
okay. Live coding is hard.
Yeah, so we kept getting this this unknown instruction.
Right. So it says that program counter 0. It found a byte that had the value 0, and it doesn't know what that instruction is, which is kind of to be expected at this point because you've called load file, and it's gotten the data out from the file, but you haven't actually done anything with it yet. It gets returned by load file on line 57, but then we just throw the return value away there because we're not doing anything with it.
I see.
So what we've got to do after we load the file is decide to do what we're going to do with that data. So back up on line 12 where you have it assigned into something, assigned into the variable file, we've got to do something with all that. And we've got to break it up basically into a loop and loop through all that data that's in there and then store that in memory very similarly to how it's stored down there on line 43, 44, 45.
Okay, so it's kind of doing something like this.
Yeah, exactly. So we're going to do something like that, except we don't have that program array at our disposal anymore. One unobtrusive way of actually doing this would be to read the file in as a giant string, and then take that giant string, write some code to turn it into an array, and call that array program, and then you can just use the same loop on 43, 44, 45 as you did before. But somehow we've got to transform this data, and data transformation is a really common task. We've got a big chunk of data that you just read out of a file, and you've got to transform that data that has blank lines and comments and stuff in it. You've got to transform that into an array that just has the number strings in it.
Okay, yeah, that makes more sense. So it can iterate over and do something with the data.
Right.
Okay.
So then the question is, how do we take that file that you read in, and how do we actually break it down into individual components?
Yeah.
So let's start off. You could probably start off on line 12 and a half and just console log file, just so we can see what it is. And give that a run. And so we got the whole file.
Yeah, okay.
That's good. We just need to extract all that stuff out of it. So William had an idea there.
Split by line, break and push. Oh, okay. So I would have to make like another function to
This is sort of a judgment call. Should you put it in a different function, or you could lump it all in the load memory function? There's no real preference I have. It's a matter of, does it read cleaner one way or another?
Okay, I think I have more direction now. I don't want to hold up, all the time for questions. But yeah, thank you. I'm going to try a few things, and I'll let you know.
It's the general approach is going to be split the thing up by line breaks, and then get those into an array somehow. Either make a temporary array like the one that's called program and load it up with strings, and then use that 43 or 44, 45, 46 just as is.
Okay.
Or another option is to load an array up with actual numeric values instead of strings, and then then you wouldn't need the parseInt on line 45. There are all kinds of options here, and there's no really one correct way to do it.
Okay, yeah, that makes a lot more sense now.
And yeah, AJ notes that \n is a line break. Usually, it depends on the platform you're on. You're on a Mac, so yeah, \n is a line break. There's, let me post something here. There is a better way to detect line breaks. It's more platform independent because Windows has a different end of line actually than Macs or Linux does. It used to be they were all different. It used to be Macs were one thing, Windows was something else, and Unix was something else. But since Mac switched to be more Unix-like, at least we got rid of that. Let me see here. So I'm going to search for node split line break. Let's see if I saw something earlier on Stack Overflow, which is my first hit here. And somebody gave an example I really liked. It was this. Here we go. Other OSs than Mac OSs. String, I'm going to type this into Slack right now.
Here, I'll stop sharing.
So when you split, you can specify, I can start sharing. You can specify a string to split on. So like split on a new line. This is a Mac and Unix style new line. If we did \n. If we were splitting on Windows, we would split on the string \r\n, which is carriage return new line. But if you want to have your code portable, it works on both of them, or at any kind of new line, you want to be a little bit more liberal about what you'll accept, either one of those or the other. And it turns out we can use a regular expression to split on. We haven't really talked about regular expressions much in the curriculum, I don't think, but it's a way of doing pattern matching. And regular expressions can handle characters that might or might not be there as well. And so the regular expression that I liked was this one. And oops, I need some slashes around my regular expression. Sorry. Slash, \r, and plus. I think that's it. So what that regular expression means, the slashes on either side mean this is a regular expression. And inside that, we're saying match one or more carriage returns or new lines. So it's a good little regular expression that will match on Macs and PCs. So if you want to split on new lines, that's a good one to do. Why PCs still have a \r, the carriage return, is beyond me. It seems like by now we should have all moved on. But that should take your big file variable. If you run split on that big file variable you had, it should then give you a big array of lines. One line per array element. And then you have to do a little bit more logic to see if you have a line that has a value on it or not. Because like William said, go ahead and use slice 0,7 to pull out the first 7 characters of the line. But what if the line starts with a comment, or what if the line is blank? You'll probably have to do some additional detection in there to ignore lines like that and throw them out. And then, like I said, the next step after you split the lines up and you get the numbers out, the next step is to stick those into memory before you start running the program using that cpu.poke, just like the existing code sort of does. Did I see something else go by about, process argv2? Oh, yeah. So that our process argv2 will have the file name in it. And then it gets to be pretty cool because you can run individual programs. Let me actually see if, CS8 was here. I must have done this for a previous cohort. Because then you can run it like this, assuming I have this working. And we can just run different programs just by changing it on the command line. Filtered with parsint. All right, yep. That sounds like a totally valid approach. Lots of different ways of doing this parsing. This is a great example of the way programming can be creative. A lot of people, when they first start programming, they think, oh, there's just like one right way to do this. And some ways are more right than others, but there are a lot of ways that are still right. And regular expressions are pretty awesome for pattern matching. We'll get to those in a couple weeks, or 4 weeks. Lots of functional programming techniques. Map and filter and map. Look at that. I love it. So you get your file data, you trim the leading and trailing white space, you do your split. Oh shoot, did I leave off the /G? Is the /G required? The /G probably shouldn't be required, but I'm not sure. Shh. All right. So yeah, what do we do? You got the program lines. You do parseInt, and then you convert it to string. And that parseInt, you've got that in there because you're going to get a nan out of it if it's not working. So you filter it out. So you filter out all the lines that aren't nan. I like that. And then this is the workhorse of the thing, right? Oh, and then you put leading zeros on it, which is cool, but probably not actually necessary because I think parseInt will work without the leading zeros on there. It sucks that JavaScript doesn't have a good way to quickly pad a number with leading zeros. It makes me unhappy. But leading zeros on a binary number, in the mathematical sense, to be clear, leading zeros on a binary number in the mathematical sense make as much difference as leading zeros on any other number. If I tell you I have 26 apples, or if I have 0, 2, 6 apples, that's still 26. The leading zeros don't hinder things. The only gotcha, of course, is what I mentioned earlier about octal. But yeah, to get it to look more like the arrays, totally. I wonder if starts with can take a regular expression. I didn't know starts with was a thing, actually. If it can, then you could replace it, of course, with starts with /0 or 1. In a regular expression, when you have the angle or the square brackets like that, it means match any of the characters that are in this set. So that regular expression will match either 0 or 1. That's a great website. What else we got going on, guys? We've got 10 more minutes before the end of the day. There's also a regex website called regex crosswords, I think. It's a regex game where you have to make regexes that it sounds like the end of the evening for you then. You have to make up regexes that solve like two-dimensional grids of. Oh, denied. They're really explicit about that denial too. They're like, oh, you can't start it with exactly that. They went out of their way to let you know that a regular expression was not allowable. Yeah. It reminds me of there was a list of classic error messages from a C compiler for Apples a long time ago, and it just had somebody went through and did a dump of all the strings that were in the compiler, and they found all these weird error messages, things like too many errors on one line, make fewer, stuff like that. All right. Other questions about the code here? Any of the steps that we were working on, or oh yeah, I heard through the grapevine that somebody was asking about the branch table. Sometimes also called a dispatch table. Flags, maybe. It's either tomorrow or the next day, I think. They definitely make an appearance in the sprint challenge, so. Anybody want to see anybody want to talk about the branch table stuff? Like I said earlier, if you don't use a branch table, it's no big deal. It's a little bit faster to just have a big switch statement because you don't have to make a function call like you have to do with a branch table. But sure. So the gist of it is that, let's see what we got here. The gist of it is, wouldn't it be nice to clean up this code a little bit? So I've got this switch statement. Not so bad right now because we just have 3 instructions. But if I do the full CPU, it's got like 40 instructions or something. The switch statement's going to be kind of huge. And so the program would be a little bit ugly. Wouldn't it be neat if we could just figure out a function to call based on this and call that function to do the individual pieces? So maybe replace this chunk of code with some handler that would do the right thing somehow, and maybe we'd pass it some arguments like operand A and operand B because it might want to use those. But of course, we don't want to have one handler for the whole thing that just pushes it off. What if we had individual handlers for each different instruction? Maybe an array of handlers, and then we can do something like this. This is a kind of obtuse piece of code. So maybe I'll split this apart. And then we'll call function H with operand A and operand B. So the idea here is that we look up a function by whatever value is in the instruction register, and then we call that function. So the only question now is, how do we actually set up this big array of handlers, and what do these functions look like? It looks like I'm having each function accept operand A and operand B as arguments. But we still have to set this thing up. How would we set up this big array of handlers? So I want it to be indexed by the instruction value. So it's going to be indexed by like one of these numbers. Should probably use, oops, should probably have it in this. So let's initialize this thing. We'll do it right up here in the constructor. This dot handler, I'll make it an array. And then I'm going to initialize individual elements in it so we can look them up by index. I'll make a function called handle LDI. I don't have that yet. We're about to get in a little mess with this keyword. So basically what I'm doing here is I'm copying this code-ish right here, the pseudocode we have. All right. And then what does handle LDI need to do? So the idea now, let's step through that code and tick and see how it works again. So we load the instruction register with the number of an instruction, like LDI or add or whatever. We look up our operand A and operand B. And then let's say it's an LDI instruction. We look up this dot handler LDI to see what that is. And of course, we initialized it here to be equivalent to this function right here. So this looks up the function, and then this line calls it, and it passes operand A and operand B as parameters. And what the function has to do is the same thing I used to be doing right here in the switch, which is that. So I've kind of broken out some of this functionality now. My big switch is gone, and now I have an array of functions to call. Probably. This hander. But let's see here. What's going to happen when I run this? I've got at least 2 bugs in it I know of. Anybody have any ideas? The whole concept behind the branch table or the dispatch table is that we'll use an array of functions. We'll look up which function to call based on some number, in this case, based on the instruction register, the IR, and then we will call that function to do the work for us. Let's give it a shot. I like thinking about what's going to happen beforehand, but let's have a look. Blah. All right, line 27, handle LDI is not defined. I was kind of expecting an infinite loop, but I just have a plain old error. What do I have to do to fix this? I've defined handle LDI inside the class right here. So why can't it find it? Does anybody know? Bind it. I will do that. That's jumping to my next question. Yeah, I got a 2-part answer. Good teamwork there. So we definitely needed this here. So let's see what that does. All right, on line 126, it says cannot read property reg of undefined. Line 126 is way down here at the bottom. Of undefined, it means that this is undefined. And of course, it is undefined for exactly the reason Edward said. We need to bind it. Because when you make a call, when you make a call into a function that you have a reference to, this is not automatically bound to it. So there are kind of two options for making that happen. We can just do it right here. Blah, that was a lot of typos. So I think that should make it happier, because now the value of this will be set correctly inside here. There are a couple other options. I want to throw one of them at you because you might see this in the future sometime. There is, well, let's see, in our actual call right here, there's a way to call to set the value of this, and it is using the .call property of a function. And when you do that, you can specify a this value right at the front of it. So you might see this pattern from time to time in JavaScript where somebody has a function and they want to call it and set this explicitly. And so the first argument to the call property is whatever you want this to be. So you might see that as well. But you guys have probably already seen bind. So let's go ahead and put bind right there. So now hopefully this is no longer undefined down inside our handler right here. What do we got now? H is not a function. What did I do? I honestly didn't expect that one. This dot handler is that. This dot handler LDI is that. H is not a function. H is not a function. I'm going to turn on my debugging output and see what's going on. Is this happening immediately? Oh no, it does some stuff first. Look at that. We go to at address 0, we got our LDI instruction, and then at address 3, we got our PRN instruction, and then it pukes. It says H is not a function. Why? Why is it puking now? I think H should be a function, shouldn't it? Let's print it out. What is the value of H? Undefined. Does anybody help me out here? Why H is undefined at this point? It was a function to start. For LDI, we have a function. But for PRN, we apparently don't have a function. What do I have to change? Is anybody still here? It's after 5. We need to add in a PRN handler. I just simply haven't done it yet. Yeah. So I'm going to actually put a little check in here. Like I used to have this check down here to handle undefined instructions. So I'm going to put in a different check right here. I'm going to say if H is undefined, then let's, undefined need. Where did that come from? Then let's go ahead and print some stuff out that we have an unknown instruction. Now let me run that again. All right, a little bit better. Unknown instruction. Oh, then I need to return. I need to stop the clock and I need to stop this function. All right, that should clean it up a little bit more. Ha! So let's go ahead and add the handler. Exact same procedure is going to take place here. I'm going to add a PRN handler, handle PRN. Down to the bottom, I'm going to rip this thing and copy it and put this handle PRN here. And then I'm going to steal what I used to do for PRN from my switch statement, this line, and drop that in here. Now what do we got going? Ha! All right, it did print out the number 8, so I'm getting closer. And then we got an unknown instruction number, or at address 5, and an instruction 1, which I remember is the halt instruction. So one more thing, and then we'll finish cleaning up the code the rest of the way. Halt. I swear I'm hitting escape before I hit L. VI failure. Okay. So add it to the jump table, add a handler here, and then I'll copy my halt code out, which just calls stop clock. And then we'll make sure this works. All right, it prints out 8, and then it halts. So jumping back here into the tick function, I can comment out my debug line. And I can axe all this code here. I used to have this big switch statement, which could have been even bigger if I had more instructions. And I'm just going to blow that away. And now the tick function is rather simplified. It's only a few lines of code. Read the instruction register, get operand A and operand B, figure out the right handler for that instruction, make sure it's defined, and then call it. And then go on to the next instruction. So it's a lot easier to reason about the code in some ways because it's so much simpler to look at. It's so much shorter now. And all of our other code is broken out into specific functions that do one thing only. And if you want to hunt through the code to find out exactly how a particular instruction is implemented, you just have to search for handle underscore that function name. That's it. What do you guys think? It's almost a matter of preference, like I said. Big switch statement or a jump table. The concept of having an array of functions, though, that's something that happens fairly frequently. Well, I shouldn't say frequently. It's something that I would be surprised if you did not stumble across in your career. And it's kind of a powerful notion, too. If you have a whole pile of functions, being able to choose them, choose which one to call by number or by some other key, actually kind of a powerful notion. If you don't redo your whole switch table, that's totally fine. The switch table, like I said, is faster. Why? Why would it be faster to use a switch table? Like the code will run faster. What is the switch table doing that's different that causes it to be faster? Or rephrased, what is the jump table doing differently that causes it to be slower? No calls were made. Yeah, every time you do a function call, there's some overhead. It has to push values on the stack. It has to do all kinds of management. It's not free to make a function call. It's cheap. I mean, you shouldn't stop making function calls because you're like, oh man, that's overhead. But if you're doing a whole lot of function calls, and if we were making an emulator that needed to be as fast as possible, an argument could be made, hey, you should probably use a big switch table, a switch statement, because that's going to be faster than having function call overhead every single instruction. Plus, the switch table, by the end of the week, it's probably not going to be that big unless you decide to go all out and implement every single instruction. And even if you do, it's still not the end of the world. I'm glad the week is starting to be amazing. My goal is for it to start to be amazing as early as possible. There are a lot of people that a lot of people can become web devs, but not every web dev has written their own programming language interpreter. One thing about dealing with big problems like this is that the regular day-to-day problems become a lot less intimidating. You'd be like, oh yeah, well, that's kind of hard, but did I tell you about the time I wrote a CPU emulator? Another thing that you might notice, like about the black box, is that the machine is pretty simple, right? I mentioned this before, that each individual instruction doesn't really do much. It's just kind of amazing that you can have such a simple machine that can store a few values and do a little bit of math, and somehow all that comes together. And you get complicated output. All right, anything else before we call it a day? It's 1:15. I might have to run outside and get a little bit of sun before the day is up. Is it summertime where everybody is now? It's lovely spring here in Central Oregon. Finally. Spring and long days. Oh, boo. It's always summer in Texas. Sounds like that should be the name of a TV show. They did say we might get afternoon thunderstorms here, but it hasn't happened yet, so maybe I'll go brave it. All right, gang. Well, hopefully that was a productive Q&A. We'll talk tomorrow more about stacks. We'll talk about stacks, how that works. All right, gang. You have a good evening. I'll talk to you tomorrow.